Whether it's the smartwatch on your wrist or some tiny sensor out in a farmer's field, we're literally surrounded by billions of smart, connected devices. It's kind of crazy when you think about it. But have you ever stopped to wonder how they actually talk? How does that little sensor send its data from the middle of nowhere all the way across the world?
I mean, it seems super complex, right? You'd think it would take mountains of code, crazy networking libraries, a totally different system for every single device. But what if I told you that underneath all that complexity, a huge number of them rely on a really simple, universal language? And get this, it's been around for decades.
Yep, that's really the secret. There's this common tongue, a basic set of instructions that pretty much any piece of communication hardware can understand. We're talking everything from ancient dial-up modems all the way to the latest 4G and 5G modules in brand new devices.
So what is this magical language? Well, it's built on something called AT commands, and the name itself is the biggest clue. The AT literally stands for attention. Seriously, every single command starts with AT, and it's basically like walking up to the hardware and shouting, "Hey, listen up! I've got something for you to do." It is that simple. A direct, text-based way to tell hardware what you want. And this right here, this is the real power of AT commands. It's all about accessibility. You can just forget about needing some complex development environment or fancy compilers. With these, you can literally just open a simple terminal, type a command, and get an immediate response right from the hardware itself. It just completely flattens the learning curve. And that opens up the world of connected devices to, well, just about anyone. Okay, so theory is one thing, but let's actually see how this works in the real world. We're going to take a brand new cellular module and we'll walk through the absolute first, most critical steps, waking it up and getting it online. You can think of it like the device's very first handshake with the rest of the world. All right, first things first, we send the simplest command that exists, just the letters AT. That's it. This is our attention request. We're pretty much just asking, hey, are you there? Can you hear me? It is the most fundamental check to see if our communication line is even open. And if everything is hooked up right, the module replies with a beautiful, simple, okay, that's it. That's the module telling us, yep, I'm here. I'm ready. What's next? Boom. Communication established. Okay, so we know it's listening, but can it actually talk to the outside world? We need to ask about its surroundings. The command AT plus CSQ is our way of asking, so how's your connection to the cell network? You got good signal? And what we get back is something like this, plus CSQ 3199. Now, I know that looks a little cryptic, but it's actually super simple. That first number, the 31, that's signal strength on a scale of 0 to 31. So 31 is perfect. It's like having 5 bars on your phone. The 99 just means the error rate is basically 0. The bottom line, we have an excellent signal. So we've got a great signal, but does that mean we're actually on the network? For our final check, we use the command AT plus CGREG. This asks for the network registration status. It's basically us asking, hey, have you properly checked in with the cell tower? Are you officially allowed to talk? And this response, plus CRG reg 01, is exactly what we were hoping for. That second number, the 1, is the key. It confirms we are registered on our home network. We are officially online. Think about that. In just 3 super simple commands, we've taken a piece of hardware that was just sitting there and turned it into a fully connected device, ready to go.
Okay, so our device is online. Now for the main event, actually sending some data. To do this, we're going to use a really popular protocol for IoT stuff called MQTT. The easiest way to think about it is like a super lightweight, super efficient postal service that's designed just for these kinds of small, simple messages. It's a pretty straightforward 4-step process. First, we have to start the MQTT service. Second, we connect to a server. Third, and this is the important one, we publish our message. And finally, we disconnect and shut things down cleanly. So let's just go through it one command at a time.
Okay, step 1. The command is AT plus CMQTT start. This tells the module's brain, its firmware, to get everything ready for MQTT. It's kind of like turning the key in your car to start the engine before you actually go anywhere. And just like before, we get a nice, clean confirmation. That plus CMQTT start 0 response just means success. So the MQTT service is now up and running in the background, just waiting for us to tell it what to do next. All right, step 2, connect to the server.
With MQTT, the server is usually called a broker. The command, AT plus CMQTT connect, is where we give the module the server's address and tell it how long to try and connect. This is the big one. This is the command that actually reaches out across the internet.
And we got it. Success. The plus CMQTT connect 00 response confirms that our little module has successfully traveled across the internet and made a solid connection with that server. We are now linked up and ready to send our data. Okay, this is it. This is the moment we've been waiting for. The AT plus CMQTT-PUB command is how we actually send our message. In this command, we're telling it to publish to a topic called ZN11. You can think of a topic as just a channel name, a place to send the message. And that last number 10 is super important. It tells the module, get ready, I am about to send you exactly 10 bytes of data. The second we hit enter on that command, the module replies with this single character, greater. That's our cue. That's the module saying, okay, I'm ready, give me your 10 bytes. So we type our message, maybe something like, hello IoT. We hit enter, and the module sends it off. And then we get that final beautiful confirmation, plus CMQTPUB 00. Message sent, mission accomplished. So look at that. We connected to the network, and we sent a message. But honestly, we've only just scratched the surface. The full AT command set on a modern module, it's like a whole universe of functions. It gives you direct, low-level control over almost every single feature of the hardware. And the possibilities are just huge. I mean, you're not just sending data. You can send and receive actual SMS text messages. You can get super precise GPS location data. You can set up secure, encrypted connections for sensitive information. You can manage files on the device, control Bluetooth peripherals. You can even make and receive actual voice calls. It's a complete toolkit for building pretty much any connected thing you can dream up. So, why does any of this matter? Why did we just spend time looking at these seemingly basic text commands? Because their simplicity, that is their superpower. It's the very thing that makes this whole Internet of Things world possible at such a massive scale. Think about it, because you don't have to be some super specialized embedded systems engineer to get a device online. The barrier to entry for creating something new is just incredibly low. A student in their dorm room, a tinkerer in their garage, or a giant R&D department at a huge company, they can all use the exact same simple, accessible language to start building. That's what this is all about. This simplicity is what fuels real innovation. We've just seen how, with just a few lines of plain text, you can give a voice to pretty much any object. You can make it know where it is, what's happening around it, and let it talk to the entire world. So now that anything can speak, the only question left is, what are you going to build?